Section 4.6, graphs of trigonometric functions. So we had a lot of focus on sine and cosine. Now we're going to look at the other four, starting with tangent and its reciprocal cotangent. So if you remember from the unit circle, tangent doesn't exist at some of those values, okay, because you're dividing by 0. Graphically, how that translates is we get some vertical asymptotes. So the period of tangent and cotangent are pi. They're half the amount because every pi units on the unit circle, you get an undefined term for tangent. So that's now our period. That is the cycle that tangent goes through. So domain and range, both x and y are elements of the real number system. However, because of these vertical asymptotes, the domain cannot exist at pi over 2 and then any value of pi added onto that or subtracted, any whole value. So pi over 2, add on a pi, 3 pi over 2. Or pi over 2, subtract a pi, negative pi over 2. Subtract another pi, negative 3 pi over 2. And then because the domain cannot equal those values, that is what the vertical asymptotes do equal. Notice that kind of opposite information there. The domain cannot equal these because the vertical asymptote does equal them. Cotangent is pretty similar, except our vertical asymptotes exist at whole values of pi. So 0 pi, 1 pi, 2 pi, negative 1 pi. And then the vertical asymptotes equal the values that are excluded from the domain. So for tangent and cotangent, they're actually pretty nice to graph because all you really have to do is figure out where the vertical asymptotes are. We don't see too many crazy transformations occurring with these. So sketch a graph of y equals tangent of x over 2. So here's the thing. We really want to find the vertical asymptotes. All right. So x over 2, there's a transformation happening there because we have something happening to our x value. Well, our vertical asymptotes should equal x equals pi over 2. So with our transformation here, take what's in there. X over 2 equals, let's look at the negative pi over 2 vertical asymptote. Let's look at the positive pi over 2 asymptote. If we solve these, we end up with x equals negative pi for that vertical asymptote. Here we get x equals positive pi for that vertical asymptote. So what that tells me is that those asymptotes have been stretched out a little bit, okay? And one of those tangent waves is going to fit in between there. Here's another way of looking at this. The period for tangent should equal pi, okay? Should equal pi. Divided by b. It's a little different than sine and cosine. Sine and cosine, the period equaled 2 pi over b. Well, now for tangent, it's just pi over b. Up here, our b value is 1/2. So if we take pi divided by 1/2, we get 2 pi. So instead of 1 pi in between of our vertical asymptotes, now we need 2 pi. So our vertical asymptotes get spread apart. So when we go to graph this, tangent goes through the origin. So let's look at pi, 2 pi, pi, sorry, it should be negative pi, negative 2 pi. So our vertical asymptotes are now negative pi and positive pi. And we'll just put those tangent waves in between. So from this vertical asymptote through the origin to the next. Here we'd see the bottom half of one of those. Here we'd see the top half of one. And we have a good enough graph for tangent just based on those vertical asymptotes. Now the graphs of the reciprocal functions cosecant and secant. This information is in your textbook that you can copy down. Essentially we have vertical asymptotes happening again, but I have a little trick for graphing these. You notice how for the cosecant graph, they see sine, they kind of put it in there. And then for secant, they took cosine and put it in there. So what I like to do for graphing cosecant and secant, I actually like to graph their reciprocal function first. Okay, I like to graph sine or cosine, and then I use that to just put in these little loops that we see. Okay, I'm going to kind of walk you through that with one example of how I'd go about that. So we're going to look at a cosecant graph. So what I'm going to do is I'm actually going to graph two sine of x plus pi over 4. That's the graph I'm actually going to look at. So I have an a value of 2. What that does is that moves my maximums, minimums. Those are now at positive and negative 2. I have a c value of negative pi over 4. That shifts my starting point, because I always kind of start these graphs at a point and then just count by the quarters. That shifts my starting point pi over 4 units to the left. And those are all the transformations that are happening. So let's go ahead and get this graph in here. And we'll go negative 2 pi to positive 2 pi, because that's the kind of mood I'm in today. There was no change in the period, so my quarters are going to be pi over 2 values. Then 2, 3, 4. 1, 2, 3, 4. So, yeah, we're good. Sine starts at a 0 and goes up. All right, so my starting point would be here at the origin. But I shifted pi over 4 to the left. So that's now my starting point. Now what that does, that means my zeros, maximums, and minimums are always going to occur in between the quarter values that I have marked. So go a quarter value over in between 0 and pi over 2, I should be at a maximum. Go another quarter value over in between pi over 2 and pi, I'm at a 0. Go another over, I'm at a minimum, negative 2. Go another one over, I'm at a 0. And then do it the same way going this way. In between these quarter values, I'm at a minimum, 0, a maximum. So, there we go. That is my sine graph. That would be the sine graph for these transformations. Now what I want to do is I want to graph the reciprocal, okay? Now the first thing I want to realize is that the reciprocal of 0 does not exist. So wherever I have zeros, those are going to be my vertical asymptotes. The reciprocal of 0 does not exist, so the reciprocal of this function cannot exist at those points. Those are my vertical asymptotes. Then, let's go ahead and look at my maximums and my minimums. Okay? The maximums and minimums, they are shared with the original and the reciprocal. So what that means, I go ahead and graph this. I'm going to, this dotted blue is kind of opening down. So that means that we're going to open up. In this little interval here, it's an opening up kind of loop. So the reciprocal is going to open down. Open up, open down. So when I go to graph cosecant and secant, let's go ahead and use the knowledge I already have, graph sine and cosine. Where you see zeros, those are going to be your vertical asymptotes, and then you're going to put those loops inside of the vertical asymptotes and link up with the original graph at the maximums and minimums. So here's another example you can try. Check the answer in my completed notes.